Convection currents cause turbulence, especially for low-flying aircraft. An updraft is an upward current of warm air. Heat rises, so on hot days, the sun heats up the ground, causing the air above the ground to head in an upward direction. Think of this as similar to a wind coming up directly from beneath you. The opposite effect happens in areas where heat from the sun is retained in areas such as wooded or heavily vegetated areas, leading to the downward direction of the air from above. This phenomenon is called a downdraft, which is a downward current of warm air. The combination of these effects is called convection currents. These currents are most noticeable on hot days next to larger bodies of water, such as a lake, ocean, or river. Which means if you go from flying over a hot, flat bit of land and fly over a body of water, you may notice the effect the sudden change in pressure has on your drone, and if you're not careful, you may bear witness to the sad and sudden end to your flight. During the day, the sun shines down and heats up both the land and the water. However, the land heats up quicker than the water. So what happens is the air rises above the land and moves over to a cooler, lower pressure area above the water, pushing the air that was above the water up over to the land, and the cycle repeats. This phenomenon is called a sea breeze. Conversely, at night, the opposite effect occurs. As the sun sets and the area cools down, the water yet again changes temperature more slowly than the land does, so the warmer air rises up from over the water and moves over to a cooler, less dense area, which is over the land, and then is pushed back out towards the sea. This phenomenon is called a land breeze. Similarly, just like around obstructions, flying low altitude over mountainous areas can be just as dynamic for flight patterns, only that much more amplified due to the size of the mountains as opposed to buildings and cars. When flying in a mountainous area, it's best to stack the deck in your favor as much as possible by gathering as much information as you can before takeoff. As air currents move up the windward side of the mountain, the upward current helps to carry you up over the top of the mountain. Conversely, on the other side, as the wind currents flow down the mountain, the tendency is for the aircraft to be pulled into the side of the mountain. The greater the wind force, the greater the downward pressure on the aircraft. Wind shear is categorized as any sudden change in wind speed or direction over a small area. The most impactful type of wind shear is called a microburst, and they're very dangerous for your drone. A microburst is a downdraft of air, typically 2.5 miles wide at the most, and usually within a thunderstorm. What happens is with the development of a thunderstorm, rain and hail can be suspended within the updrafts of the storm. The updrafts cause warmer air to rise, but what this does is it keeps the hailstone suspended in the air until the evaporating cooling weakens the updrafts, and all that rain and hail held up there comes crashing down to the ground. As it hits the ground, that wind and the hail spread out in all directions, leading to microbursts of high winds and damage at the ground level. Downdraft speeds can fall as fast up to 6,000 feet per minute and last anywhere from 5 to 15 minutes. That's it for this video. Thanks for joining our discussion on the wind effect on drones. If you have questions, please post to our discussion boards. Don't be shy. Have a great day, guys. We'll see you in the next one.